From the display in the upper right, we see that the Fluke 805 vibration meter takes three measurements: high frequency, overall vibration, and temperature. Let's look at the difference between these vibration measurements and screening. Overall vibration is taken over a set frequency range of 10 to 1,000 Hertz. We add up all of the RMS amplitudes and average them into one number. See the equation in the big yellow box. It reflects the energy of all vibration peaks over the entire frequency range. See the graph at the bottom. The shaft harmonics are the major contributor to the overall vibration. Overall vibration analysis does not require extensive training to implement. We get one simple number. Overall vibration meters are valuable as screening tools. If an adverse trend is identified, a more thorough test should be performed to validate the problem and identify the root cause. A key limitation to overall vibration is that bearing flaws will not cause an alarm in the overall vibration level until significant damage has occurred. See the overall vibration graph at the top. Most of the energy is coming from the large peaks from the rotating shaft. When a bearing is first starting to fail, very short duration spikes will appear each time the flaw makes contact with an adjacent bearing component. These spikes are very low energy and therefore cause very little change in the overall vibration. See the graph at the bottom. In an effort to better identify early signs of bearing damage, some analysts began using Crest Factor, which is the ratio of peak over RMS of a time domain. RMS is root mean squared. Crest Factor is very good for identifying early signs of bearing wear. See how the peaks from the bearing impact stand out from the noise floor in the middle graph. However, a problem occurs as the bearing damage worsens. The significant bearing damage causes the RMS value of the time domain signal to increase significantly. See the plot at the bottom. The noise floor is growing as high as the spikes. Since RMS is in the denominator of the Crest Factor ratio, this actually causes the Crest Factor value to decrease. The analyst would see the low Crest Factor and could not be certain whether the bearing was healthy or near failure. In an effort to overcome this problem with Crest Factor, the Fluke 805 utilizes a proprietary algorithm known as Crest Factor Plus. The Crest Factor Plus algorithm, seen at the top of the slide, includes the traditional Crest Factor value, but adds a value from the RMS noise floor to reflect damage seen as the bearing worsens. This is a significant step forward from traditional Crest Factor vibration because the output value, Crest Factor Plus, increases continually as the bearing damage worsens. The Crest Factor Plus values can be related to bearing damage according to the severity chart in the middle. In the lower right is an example graph that shows ordinary Crest Factor in blue varies from 3 to 7, but then back to 4 as the bearing worsens, where Crest Factor Plus, the red plot, increases steadily from 3 to 12 as the bearing damage worsens. The final topic we'll cover is severity. The severity scale gives the user more than just a number with no meaning. It provides a better understanding of the machine health and what action should be taken. There are two severity scales. One severity scale is the Crest Factor Plus and shows the bearing health. See the green circle and the box. This scale does not depend on a machine type and does not require a machine category during setup. It is displayed anytime the measurement is taken, as long as it's greater than 600 RPM. The other severity scale is based on overall vibration and shows the machine's health. See the purple circle and box. This scale depends on the comparison of the one of the 37 machine categories to be selected during setup. If the machine category is not selected, the severity scale will not be displayed. It will be left blank. If your machine is not on the list, then the database does not have overall vibration levels stored for comparison. Even though you won't see a severity scale for overall vibration, you'll still see a severity score of Crest Factor Plus along with the 3 readings: overall vibration, Crest Factor, and temperatures. Simply trend the overall vibration levels over time and make your own alarm levels.